Hi everyone, welcome back to another Julia language tutorial. Last time we created our swap and annotate logic for our image puzzle game, and the game actually starts to look much better now, and it's almost done. This video we will refactor our code a bit, mainly for performance reasons, but not entirely. We will also create some better separation of the code, the logic, and we will create composite types, also known as structs. So the main incentive to use structs, it comes from the to-dos in the Julia performance tips. So you can see under the Julia docs, we have this performance tips, and the first item is avoid global variables. You can I'll link this below. You can go and see for yourself the tips. So as Julia strongly recommends to avoid globals, this is what we want to do. Currently we have some inner state of the game that we need to pass, the first click, the image itself, all sort of things, and we want to avoid those global declarations. So we will create a composite type, actually storing the state of the game, which we can pass to the functions we will declare. So composite types are created by using the struct keyword. This creates a user-defined type. This is not an object as you might know it from other object-oriented languages, and it doesn't have any inner methods related with this object. When you declare a struct, the default struct is unchangeable after creation, meaning you create a struct, you cannot change its fields it holds. To do so, you need to define it as a mutable. And let's just dig in and code. So I'll open our puzzle game, and right in the beginning I'll start with a mutable struct. This is the code this is the block that gives us the ability to define the game state, and we'll end it. So first off, I want to declare a special type of a struct. It's a parametric type with respect to t. T will be a colorant, and it will be actually the type of the image. So we'll have a different game state for each image, and now we can declare all of the fields we want for the struct. So the first one will be the input image, and as we know it's an array of type t and 2. We want to declare the shuffle image. This is the current state of the image, also t and 2. T and 2. We have the GUIDict, storing the current state of the aim show. It's a dictionary from strings to any. Next thing is two main state variables. One is active, it's a boolean, and the other is first click, also a boolean. Next is the initialize values for number of blocks, and the block size. So both are actually a tuple of integers. So this is in respect to rows and columns, and the block size also in respect to the width and the height. And I can leave the spaces. And last thing is the box handler. So the box handler is actually what we've defined in previous as the annotation handler. It's the handle to the annotation. So it's an annotation handle of type anchored annotation and anchored annotation, which is also a parametric type of the annotation box. And just to make sure, all of these are coming from image view, and I'll state it to be clear. So it's from the package image view, the annotation handler, and from the package image view, the anchored box. We're starting with no handle, so I'll actually create something called a union of two types. So it can be either nothing or the specific type we've declared. The next thing is the swaps. I think we'll need to use it in the future. Something to count how many swaps did we make. Maybe it will be good to give a score at the end of the game, or I don't know what. So this is basically the core, or the basic fields we need in the struct to pass along the different functions. Now we need to create a new game state. We do it with constructors. You can define the constructor outside of the game state, and it's a function that has the same name as the structure. I believe it's easier and more readable to create constructors under the struct block. So I'll declare the constructor. So basically, the default constructor for every structure, for every new type, is just giving all of the fields to the struct, the new defined type. But you can define it with less fields. So I want to give, let's say, an image and the number of blocks, and this is of a tuple of 2 ints as we know it, and I can even give it a default value of 4 and 4. Yeah. And let's define the image as an array of type K. So type K, it's the constructor. It doesn't know the type of the structure, so I need to define where K is a subtype of colorant. And yeah, so we have a new function giving as input 1 or 2. The second argument has a default value, and now we can actually create the new structure with the new function. The new function is only valid if you're building your constructor under the struct block. If not, just use the default constructor with all the types. So it's a new of type K. It's a parametric type, and now I need to define all the values, and I will give them as so. I first will init the game. So I want to init the game with image, and the number of blocks, number of row blocks will be equal to number of blocks in position 1, and number of column blocks will be equal to number of blocks in position 2. And let's just remember for our init game, so init game number of blocks. So init game currently return the shuffle image, and we need it also to return the block size, and we can delete it from here. So we'll return the block size as well as the new image. And let's just see that we had a new declaration here. I can add the underscore, which means to discard it. I think in the end of the video we will delete this line, but just to make sure you don't keep any messed up code, it's more easy to go over all the instances you have of this function. So we have here the shuffle image, as it returns the shuffle image and the block size. So this is what the init game returns, and we can also declare the GUI dict, which is imshow of the new shuffle image, and let's give it a name, image puzzle game. And now for the new declaration, so we have the image, the shuff image, the GUI dict, and let's just remember for the order, the image, the shuff, the GUI dict, and now we have is active. So yeah, it's start always is active. The first click should be also true, and the number of blocks is the number of blocks, and the block size is the block size we have now. We've got from the init game. Now for the box handler, so we can initialize it as nothing, and for the swaps we can initialize them by 0. So we have our new created method. That's it for the creation of struct. Let's just check we have everything and no unnecessary typos, annotation, handler, handle or handler. Just let me check it. Handle, anchored. Seems okay. Now that we have our struct, we need to use it, and for the Julia we create multi-dispatches methods. So I think of it as if the multi-dispatch method is my analogy for object-oriented inner function, inner methods. So instead of defining inside the object the functions and method it has, I can simply create or overload existing methods with the specific new struct. So the first thing I want to do is actually overload the show function, which is the father of prints or all prints. So I need to import it specifically. I need to import base show. You need to import specifically the base function, the show function, so you can overload it, create new methods. So function show, and you'll give it the IO and the game, which is of type game state. And now you can actually define what you want to do with this function. So I want to print game, and let's open like this, and game is active. So if it's active, I want to print ongoing, and if it's not active, I want to say it has ended. And I can also specify that I conducted game dot swaps, conducted swaps. Yeah, seems nice. So we have this version of the show function. It has 2 arguments. This is what we'll get when we print the game state instance. Another method we can use is 3 arguments types, and this time we use the second type is only a type of the plain text. So it's you write it as so mime text plain. So this is what we'll have when we're in the REPL and we type the instance and we just want to see what the instance store. So this is what we'll get. I'll delete all of this just to make have something shorter. So 3 argument method, and yeah, so rather similar. I'll show you the difference between the function in a second. So we have our multi-dispatches and we know how to use them, and now we can actually go and refactor our code. So for the first thing I want to do is we'll go to our main function, and this is our main logic. So this is what happens when we click the mouse, and I'll create a new function called do click. This is what we want to do when we click, and this is our entire function. And I can indent it a bit. I won't need these globals, and just to make sure, we have 2 arguments. One is the button, and the second is our game state. The button is it's a rather complex. Just remember, it's a signal coming from the canvas mouse. It's a button press signal, and the actual type is from the GDK reactive package, and the type is a mouse button, and it's a parametric type defined by the user units. It's the type of the XY coordinates. So also from the GDK reactive user unit. So this is the type, the actual type of the signal, and we call the button all, you can see all sorts of places. Now, as we don't have the global declaration, let's check where we created, where we use these global declarations. So instead of using this annotation handler, we will need to reference it by the game state box handler, and this is the new position of the annotation handler. So just make sure all places we have annotation handler, we are replacing it by our game state. So it's here, so it's all sort of copy pasting. Very fun. And also here, it's not the box handler, it's the game state handler. That's it. We have the first click. The first click is now given as game state. It's a field inside game state, and also here, and also here, and the last place is at the top level code, and we don't need it no more because it's not a top level argument, it's inside the game state. And yeah, this is nice. One other thing is the block size. It used to be a global declared in another place, but now it's again under game state. And let's revisit the code, the annotation in the GUI dict. Yeah, so the GUI dict is again no longer available. It's under game state GUI dict, and let's just check all the instances of GUI dict. Yeah, something didn't work. So game state GUI dict, and right here we can delete this GUI dict. Yeah, game state GUI dict and game state.GUI dict. This last GUI dict is what the main function returns, and actually I want to return the game state now. So yeah, we were in our do click function here, and we changed the GUI dict. So let's check that we don't have any more variables that are no longer valid now. We change this one, game state, this is okay. Box handler, just to make sure we did it correctly. Yeah. Now for the swap blocks, so we have our margins. It's the current margin. The previous margins, we've just added them, and the new is no longer valid. It's actually called differently now. It's under game state, and this is the current shuffled version of the image. This is the name of it, and we delete the from the GUID. Yeah, this is nice. Okay, so we have our do method, our do. Let's check that we don't have any more. Yeah, we don't have any more global declarations. So we have our do click function. Coming back to our main. Last time we have the do syntax. The do syntax specify that in the mapping, in the function we've just called, we don't have the first argument, which should be a function handle. And now that we don't have it, we need to, if we didn't have it, we can use the do syntax and define the function in the code. Now we do have the function, it's called the do click, but our do click function is not really what we need, because the map, it should get one argument function. So we actually need to create something we can call a partial function. So we'll create a mapping from our do click function to another call with only one argument. So we actually, every time we will call the partial do click, we will call do click with the same button, and we'll use game state, which is declared just a few lines before here. And now we can actually use the partial do click right here and lose the do syntax, and I think we can also lose the guarded, not sure, and yeah, I have some kind of error for the end partial do click. Yeah, we don't have. And let's just look at the beginning of the main function. So we have our image, we have our game state, and now we don't need to recall the init game. We don't change just yet the signal connect, and yeah, I think we're done. So let's try and run it. Let's state is equal to main. Game state is not defined, and let's just check where we created this, where we defined this game state. Yeah, so the declaration for the declaration is just the name of the struct. Yeah, and yeah, okay, so let's swap the image. We're highlighting, we have some kind of error, so I'll kill it. So game state not defined, game stay, yeah. Game stay not defined, game state. Yeah, I hate those typos. Okay, so I have some configuration file that helps me activate the environment and include and revise and everything that we need. In a second we'll load it and we'll run it. So we've loaded and we can run again. Please notice that sometimes the first run for the function is not interactive. I don't know why. So I've just rerun it. The first call was non-interactive. I don't know why. After I just restarted a new Julia session, we don't have the guarded, so we need to create a new Julia session. It's unfortunately. And yeah, we highlighted the eyes, we swapped them, and you can see that it looked like it works for us. And let's just see what is the state now. And yeah, game is ongoing. We conducted 0 swaps. This is because we didn't define that we want to count them, and it will just state. So this is the 3 argument method on game ongoing. Excellent. Wow, so I think we've done a lot this video. We used the struct and we showed how to remove all globals and use only the composite type struct of the game state. And next time we will improve more the game. We will actually write the ending for the game, and maybe we'll cover some corner cases for the beginning, the initializing of the game. Hope you enjoyed this video. Please comment below, let me know your likes, your dislikes, everything, and don't forget to subscribe to my channel. Thank you very much.